Hello everyone, let's solve today's problem. Minimum fuel cost to report to the capital. There is a tree-structured country and it has n cities and n-1 roads. The capital city is city 0 and the roads are bidirectional. There are representatives for each city, and they have to move to the capital city using cars. The number of seats in the car is given. We need to calculate how many cars are needed to carry every representative to the capital city most efficiently. Let's look at this example. The city looks like this, and we have 2 seat cars. Representative 6 can move to city 4 using 1 car, and representative 6 and 4 can move to the capital city using 1 car. Representative 5 can move to the capital city using 1 car, and representative 2 can move to city 3 using 1 car. Representatives 2 and 3 can move to city 1 using 1 car, and representatives 2 and 3 can move to the capital city using 1 car, and representative 1 needs another car because all seats are full. So the total number of cars is 7. In this solution, the rows are given in edge list format for a graph, but we need to change it to the adjacency list format because it can be useful for graph traversal. And we need to manage the scene variable, which is set to traverse for tree, not graph, and we use sail to calculate the number of cars with limited seat counts, like this case. With tree traversing, we calculate the number of cars in post order. Let's look at this example step by step. In city 0, we have all representatives and move on to neighboring city 4. City 4 has all representatives, and we move on to neighboring city 6. City 6 has a representative, and there is no other neighboring city unvisited. So we add 1 car for representative and return 1 representative. At city 4, we add 1 car for 2 representatives and return 2 representatives. We go to the city 5. City 5 has a representative, and there is no other neighboring city unvisited. So we add 1 car for a representative and return this 1 representative. We go to the city 1. City 1 has a representative, and we move on to neighboring city 3. City 3 has a representative, and we move on to neighboring city 2. And city 2 has a representative, and there's no other neighboring city unvisited. So we need 1 car and return 1 representative. At city 3, we add 1 car for these 2 representatives and return 2 representatives. At city 1, we add 2 cars because we have 3 representatives now, and the seat limit is 2, so we need 2 cars, and we return 3 representatives. Finally, at city 0, the capital city, we don't need to move anymore, so we don't calculate the number of cars. So the 7 cars are needed. Okay, we made it. Let's code it. We are given an edge list from this problem, but we change it to the adjacency list representation. And we will build a depth-first search method. Cars variable is declared outside of this method, but if we use non-local, then we can update the value in the method. We register the city in scene variable to avoid visiting again. Each city has one representative. If the city has any unvisited neighbor city, then we do a depth-first search. For non-capital cities, we calculate the number of cars based on seats count. We return gathered number of representatives in the city. We start this depth-first search from capital city and return the total number of cars. This solution's time complexity is big of n, the city count, because we've visited every city at once. And the space complexity is also big of n, because the height of the tree can be deepened up to n at worst case. I hope you enjoyed this video and it was helpful. I will see you soon. Bye!